This is an RC car. And this is a racing simulator. Let's put them together and learn some things along the way. I like to build things, so when I get a new idea in my head, I have to make it come to life. Or at least try, until my workbench becomes a heap of tools, prototypes, and electronics, and eventually I forget what I was doing. Like most nerds, growing up I spent time with my friends tinkering on radio-controlled vehicles. We loved racing, hitting jumps, drifting, and crashing. There were never any real consequences, other than a few bits of broken plastic. We were building, breaking, and fixing endlessly. Unfortunately, the hobby followed me into adulthood. Another unfortunate hobby I picked up along the way was sim racing. Again, all of the fun, but none of the consequences. Well, still the financial ones. But none of the physical ones. Turns out the algorithm knows me well. It showed me an Austrian company that developed a system that allows you to drive an RC car with a racing simulator. I'll put a link below. Not living anywhere near Austria and being the overly ambitious person that I am, I set out to do it myself. How hard could it be? After opening up an old wheelbase, I saw it was using an encoder to get the wheel position. Trying to avoid writing any software, I decided to couple a potentiometer to the drive mechanism, allowing me to knock out the steering input with only 3 solder joints. Thinking I'm a genius at this point, I did the same thing with the pedals. Or pedal. This is where things get interesting. The transmitter wanted to see a single potentiometer used for both throttle and brake. But the pedals had one for either input. I thought I could rewire my brain and drive with a single pedal, meaning off throttle I get full brakes, 50% throttle is neutral, and 100% throttle is full gas. Genius, I was not. It was bad, bordering on I shouldn't pursue this bad. But then I thought, maybe I can just write a tiny little Arduino sketch to help with the pedal problem. If the Arduino takes the potentiometer values from both pedals, processes it, and spits out the kind of signal that the transmitter wants, I'll be done, right? Nope. Digital outputs. The PWM throttle signal sent by the Arduino gave my servos a bad case of the jitters. I had to smooth the signal. So I tried a couple RC filter circuits. They did smooth it, but it came at the cost of response time. I didn't want an RC car with a similar power to weight ratio as an LMP1 car to steer like a Peterbilt. To make matters worse, the steering sucked too. Coupling a potentiometer to the drive meant I couldn't power on the base, leading to a limp, playground pirate ship wheel feeling. So I moved on. In more ways than one. I decided to do the smoothing with digital to analog converters. They would give me the dead flat signal I wanted with real-time response. Since I was delving into more complicated electronics, I decided to let software do the heavy lifting. I thought if I capture the simulator inputs with Python, then send them over serial to the Arduino, I would not only have full control over the steering feel and response, I could give myself endless opportunities to expand the project in the future. So I wrote a script. Starting simple, I only looked at the steering, throttle, and brake inputs. I adapted my Arduino sketch to handle the new values and got to testing. It worked great. Liking where I was at, I designed a breakout board for the Arduino and DACs. But now there was a new elephant in the room. It's really hard to drive if you can't see where you are or where you're going. I needed FPV. So I got to designing a pan-tilt camera system and video transmitter mount. I 3D scanned the top brace and remodeled it with mounting provisions for the video system. Then I got to printing. By the time the PCBs arrived, I had everything working to the point where I could drop the components in and go. So I went sideways into the wall, multiple times. This little thing rips too hard for my small space, so I toned it down by adding a neat feature thanks to the Python integration. Simulated gears with paddle shifting. I can limit the throttle position based on button presses, and I can control how quickly it gets to the maximum voltage allowed by that quote-unquote gear it's in. I've also mapped the handbrake, so if I ever get a car with that functionality, like an ARMA infraction, it'll be plug and play. As I alluded to earlier, there are endless possibilities. I've modified the transmitter so that every button and switch is controlled by the simulator. Wheelbase, pedals, HODIS, doesn't matter. If it has an axis or a button, I can get the position and map it to the transmitter. The script and Arduino sketches are heavily reliant on my setup. Device names and COM ports all have to shake hands before it reads any inputs. That's the downside. I can't release this as is because your setup likely isn't the same as mine. If there's a lot of interest, I might revisit the scripts and sketches, or I can go into a deep dive into the hardware and software so that you can build it yourself. If you've made it to this point, you're a nerd like me, and you may be curious about some things on the car that I didn't explain, like the third antenna and that thing in front of the camera. These are the next steps, because what's a simulator without movement, right? How hard could it be? Doing projects like these isn't just about making something cool. It's about the mistakes you make, the problems you solve, and the unexpected lessons along the way. If you've ever wanted to build something that seems silly or borderline impossible, just go for it. You might surprise yourself with what you can figure out. Congratulations, you made it to the end of my rambling about childhood hobbies and stupid technical stuff. Now I want to hear what you have to say. Leave a comment, tell me about your projects, or what you want to see. People always say like, share, and subscribe because it helps them out. I'm new to this, I don't know what that means yet. But if you did like it, leave a thumbs up. If you have nerd friends that will want to see this, share it. And if you want more, subscribe.